Hello, welcome to this lecture. In this lecture, we are going to talk about subclassing and subtyping. The goals for this lecture is to discuss the relationship between having an API and what happens when we have a subclass of it. Also, what happens with this API and the clients of a given class. We need to compare subtyping and subclassing, and we are going to see how these concepts impact the design. Subtyping is good even in dynamically typed language. Let's start with a simple example. Let's see this snippet of code. We can see that we are defining a class poem as an extension of a linked list. What do you think about it? Of course, this code, we can write it. It's a valid code. But the question is, does it make sense? It's a good idea. If we think about the API of our poem class, the instances of poem should understood as word, where we pass a word, and then we can ask if it is a haiku or if it's in Alexandrine mode. But also, in this case, as we are extended linked list, we have a lot of methods that we should not understand. For example, add before link, or all the methods that are defined in linked list. Let's see another example. This looks a little more to have a little more sense than the previous one. We are defining our class stack also as a subclass of linked list. Of course, this code is valid, but again, does it make sense? An API that we are expecting to have in a stack includes operations like pop, push, size, or top. But all the other methods in a linked list, they apply to our stack. They are valid in the context of our object. As you can see, in the two previous examples, we have to think about the API when we are using subclassing, because the subclassing mechanism is intended to reuse code, to reuse the superclass code, and it's not thinking about the API that we are exposing to our clients. One interesting thing is that the previous examples were in our little reduced Java-like syntax, because in both cases, in dynamic typed languages and in statically typed languages, subtyping and subclassing is really useful. They are really useful. We need to use them in the good points that we care. And the subtyping and the subclassing has nothing to do with the type checker. The type checker, as we have seen in other lectures, is there for checking that we are having the variables pointing to possible good types of objects. So basically, as we said, it's just checking that we put squares into squares and circles into circles. Let's continue with a simple example. Again, we are thinking about implementing a stack. And again, we are thinking them from the point of view of the API that the client wants to use. In a stack, we want to push elements, we want to access the top element, and maybe pop in one of the elements and get in the one that is on the top. Also, we want to ask if it is empty or not, this stack. We can see that these operations have sense for our stack. We have a API that have sense and that is useful for the client. Let's see one alternative to implement the stack is to have a subclass of ordered collection. We are going to have our ordered collection that is already existing in the system, and we are going to extend it to implement our stack. Easily, we can implement the pop as remove first, as this method also returns the first element. We can implement the push as at first we are in the ordered collection always pushing and popping in our stack in the first element, and we can access the top just by getting the first element. By this, we are going to have some advantages. Implementing the stack like this will give us all the reuse of the code that is interesting in ordered collection, like the implementation of size, includes, do, collect, and so on, that are interesting for our stack. So we see that we are using the subclassing as a way of getting code reuse. We are winning the implementation, reusing the implementations that are useful for us. But there is a problem. What do we do with the rest of the API existing in ordered collection? For example, now our stack understands all the methods, all the messages that are in ordered collection. So we can add an element before a given one. We can remove different elements or access the stack in different positions, not only in the first one. Basically, what we are saying when we are making that we have our ordered collection and a subclass for the stack, we are saying that all our instances of a stack are instances of ordered collection. And that is not what we want, because a stack is not an ordered collection. Yes, in this case, we cannot, or we don't want to have a stack as a replacement of an ordered collection, because a stack has another API, it has another use, and is intended for another scenario. Again, we can see, for example, the examples of methods that are defined in ordered collection, but does not make sense in the stack. For example, we can add an element in a given position, breaking the logic of the stack, where in the stack we always access through the top of the stack, so we are breaking the stack. This breaks completely the stack, it's broken. And the same happens if we can add elements at the end, or we can remove elements from the top using remove first directly, or removing any of the elements inside. So all these methods, what they do is that they break our implementation of a stack. One easy solution that we can think as good is, okay, we are going to cancel all the operations that we don't want to expose. In this case, for example, we are taking remove first and raising an error when this message is sent to the stack. But this can get really complicated because we were using remove first in our pop implementation. You remember it's here. So we need to avoid the implementation. We can do it using super, but this is really, really, really ugly, and we should not do it because basically make the solution much complex, and it makes it more difficult to evolve in time. So, taking this into consideration, we can see that there is no a simple relationship. There is no a clear relationship between a stack and ordered collection. We are analyzing this relationship from the API. We are thinking them from the point of the client. The interface that we expose in the stack is not an extension or a subset of the ordered collection. There is no way that we can find this kind of extension. It's not that we are adding new operations to ordered collection but keeping the previous one, or just using some part of them. Let's see another example. Let's imagine we have a counting stack. This stack will count every time that we do pop or push to have an accountant of the operations that we are doing, but eventually will do exactly the same that an stack. In this case, we will have our stack and our counting stack. subclass, the counting stack, could be a subclass of a stack. Basically, it's doing the same plus a little differential. Let's compare with the previous case. We have here in a user of our code that has its program is basically using an ordered collection. And it's using an ordered collection, and this program works perfect. And in the other side, we have another piece of client code that is using the stack and is using the operations defined in a stack. And this program also works correctly. By having subclasses, we can see now that what happened when we replace our ordered collection by any of its subclasses. If we take, in this scenario, if we take now and we are using a stack, we will see that this stack, we are using it, sending the same messages that we are using to ordered collection. That works, but it's breaking the nature of the stack. It's breaking the usage of the stack. In this case, we see that an stack is not an ordered collection. In the other example, now we change it, the user of a stack, in this second user, for the user of counting a stack. And we keep exactly the same program. In this case, the program will work and will do what the client code wants, with the addition that our counting stack behind the scenes will count the number of operations. And this example works because a counting stack is a stack, has a valid API, and they are a clear replacement. So, how we implement the stack after this analysis in abstract? Well, we can implement the stack just extending from object, not breaking the relationship with ordered collection, and we can do is implement it with composition. We can do that our stack is implemented using a collection inside. Could be an ordered collection inside, and we can directly use it in this way. So it's better always to use composition before using subclassing when it's not needed. Remember, subclassing or inheritance is intended for code reuse. We are reusing the code that is defined in the superclass, and we will add a different specification in some of the parts. The idea is that we can override part of the code, but we are not going to replace all the implementations. And also remember that the more normal is that a subclass can be used as a replacement of the superclass, but this is not always true. It depends what it changed in the subclass. The consequences of using a subclass when we don't need to is that basically we start making our code more complex and making it more difficult to understand. We make more difficult then later to how to evolve this, and forces us to use strange hacks and strange code, like for example, the one that we had to use super to skip the implementation in the current class. The idea of subtyping is that we are going to inherit the interface. We are going to have the same messages that we are going to understand in all the types. We are going to make two objects work in the similar way, interact each other. A good way of thinking it is with numbers and fractions. They are completely different objects, but they have the same API, so we can make them work together. The same happens when we have collections and arrays. Arrays are examples of collection, and they should work in the context where we use collections. The same happens with fractions. We have to use them in the context where we use numbers. So what we are doing always is that a subclass, from the subtyping point of view, have to always refine, have a better, be more specific than the one defined in the superclass. One code smell that shows us that we are using bad the subclassing and subtyping is that example that we've seen before of canceling methods. This is a sign of a bad design, and eventually we are going to pay the cost of taking a bad decision now. Let's analyze this new example. We have a restricted stack. This stack allows us only push new elements that are smaller than the top element. We can implement the push in this way. What is the good superclass for this? Maybe it's a stack. It looks like what we want is an stack. But the problem with that, we need to be sure if the clients that are using them will be affected or not by this new restricted stack. Maybe this kind of behavior should be better handled in the client and not hidden in the restricted stack, but maybe it's not mandatory or possible. This depends on the problem we are solving. And also, a subclass does not have to make sure that the client program works. We can talk a little about the Liskov Substitution Principle. Basically, what it says that if we have two objects of two different types, S and T, and we have a program that works with the object of type T, this program should be unchanged or should work exactly the same when we change one object to the other if they are the S is a subtype of T. In this case, what we are talking about is the objects should have the same behavior. They should have to be what is called behavioral typing. Most of the time, we are not going to guarantee this, because when we subclass, we are going to change the behavior. Because if not, we are going to use the original object. A subclass often change slightly the behavior that we implement in the superclass. This Liskov substitution principle looks a little useless in this context, but what is important is that we maintain the idea of the API. When we are having the inheritance and polymorphism, we have to be sure that when we have two objects that we want to use them polymorphic, in a polymorphic way, we need to be sure that we are conforming and we have interfaces that we can substitute one to the other. In this way, the idea is that we can use one of the implementations or the other without caring if it's one or the other. That basically is the idea behind polymorphism. And the only way that that happens is that both objects have the same interface. When we are subtyping, using inheritance for its having subtyping, we create families of classes with the similar interfaces. And usually we create an abstract subclass that we are going to define abstract, and then we will have concrete classes. What we do with this is that we want to define in the abstract subclass the API that we want to use from the clients. when we are using this kind of abstract classes and the concrete subclasses, we are helping to reuse the code. We push the common code in the abstract subclass, and also we are ensuring that we are creating polymorphic objects. One point really important is this last point, is that, well, we can create polymorphic objects by having subclasses, by using inheritance to create subclasses of a given class, but also remember always that we can implement the same interface in classes that are completely independent or they are in different hierarchies. And this also is useful, and we are going to use it a lot when we use polymorphism. Basically, when we have extend or inheritance or create a subclass, we are mixing two concepts, because we are creating, in a way, a subtype and a subclass. We have to be sure what we are doing with it, and remembering that subclassing is about program reuse. We want to reuse the code that is in the superclass, and subtyping is about creating family of classes that share the common API. We can have subtyping without having subclassing, but always that we subclass, we are subtyping. So we have to pay attention to that. Not always that we want to use to reuse code, we are going to use subclassing. So like that, when we only want subtyping, when we only want the common API, it's better to avoid the subclassing. We need to use subclassing when it's for reusing the program code.